There are a few more things that I'd like to discuss about the solar system. So we now understand how it formed and when it formed, but there are a few other things. For example, the asteroid belt. So the asteroid belt is located between Mars and Jupiter, between about 2 and 3.5 AU from the Sun. Now, as we look at the asteroid belt, there are hundreds of thousands of asteroids in this region, meaning that there's still a lot of material. There's enough material that it's reasonable to ask, so why is it that this stuff didn't accrete into a planet? Well, based off of computer simulations, it's all Jupiter's fault. This material is close enough to Jupiter that as Jupiter orbited around, its gravity kept churning this material, so it wasn't able to continue accreting. Something else Jupiter did is its gravity actually ejected material out from this region. So overall, it decreased the amount of material here and kept it churning so it wasn't able to accrete into a single large object. In fact, we see some of the evidence of Jupiter still affecting the asteroid belt today. In this graph, what we're looking at is the number of asteroids at distances from the Sun. Okay, so on this graph, you can see where the orbit of Earth and Mars are. Then through here, we've got the asteroid belt. Notice that there are some regions where we have a huge drop in the number of asteroids. These regions are referred to as the Kirkwood gaps, named after the astronomer who realized they were there. What is interesting is that each of these Kirkwood gaps corresponds to a region of an orbital resonance with Jupiter. An orbital resonance is a region where the material orbiting in this place has an orbit that is an integer number of another object. So for example, right here, this dip, the really big one right here, has a 1 to 3 orbital resonance, meaning that every time Jupiter has orbited exactly one time, any asteroids in this region will have orbited exactly 3 times. What this means is that Jupiter's gravity keeps pulling on these asteroids in the exact same place of their orbit every single time, which is going to cause them to get swept out from this region. So each of these Kirkwood gaps actually corresponds to one of these regions of orbital resonance. So Jupiter is still affecting the location and formation of the asteroid belt even now. Something else we should discuss are comets. So, we've talked about asteroids. These are the rocky objects left over from the beginning of the solar system. But there are also icy ones. Most of these are in the region referred to as the Kuiper Belt. You can kind of think of the Kuiper Belt as an asteroid belt but made of comets and beyond the orbit of Neptune, but the idea is okay. Now, occasionally, one of these comets will have an interaction which actually causes it to fall in towards the inner solar system. As this happens, as it gets closer and closer to the Sun, it is going to heat up, which is going to cause the ice to sublimate, to go from being a solid directly into being a gas. We could also say that it is vaporized. Well, the part of the comet that is still around even in the outer solar system where it's very cold, this is what we refer to as the nucleus. This is the dirty snowball. I really like that description of it because it is a mixture of rock and metal and ices. Okay? So it is really kind of like a dirty snowball. Okay? So the nucleus begins to heat up, which causes it to begin to vaporize, creating the head of the comet, what we refer to as the coma. Then this vaporized material is going to stream out away from the nucleus, which is going to create the tail of the comet. In this case, what we're looking at for this picture is the nucleus for Halley's Comet. Halley's Comet is possibly the most famous comet. Maybe you've heard of it previously. But this was a picture the last time that it came into the inner solar system in the early 1980s. And in this case, we can actually see some of these regions where it's vaporizing, creating these jets. This is a view of the nucleus for Comet Tempel 1, which shows lots and lots of impact craters, but we also have these flat regions. These are likely the places that form into jets that are sublimating, vaporizing as it's getting close to the Sun. Now, as we look at a comet's tail, it's not actually just a single thing, it's actually 2 different pieces. We have the dust tail, which in this picture is white. This is made up of dust. So as the material vaporizes, some of the dust is going to be thrown up and will actually get caught by sunlight. Sunlight actually has a very small amount of pressure, and for how small these dust particles are, that pressure is enough to cause it to push away from the nucleus. So the dust tail is made up of dust being pushed away from the nucleus by sunlight. The other tail is the ion or plasma tail. In this picture, it is blue. This is made up of plasma, which is a whole bunch of charged particles. In this case, this is material that is becoming ionized as it's vaporizing off of the nucleus. It is then caught by the solar wind, the stream of particles and radiation blasting away from the sun, which then causes it to stream out away from the nucleus. So there's the dust tail made of dust and the ion tail made up of ions or plasma. But in both cases, they're going to be pointing away from the sun. The dust tail because it's being pushed by sunlight, and the ion tail because it's being pushed by the solar wind. So what this means is that the tail of a comet will always point away from the sun. Now, when the comet first starts out and it's way out in the outer solar system, it has no tail because it's still very, very cold. But as it pulls in closer and closer towards the sun, it begins to heat up and vaporize, starting to create the tail. Then, as it continues, more and more vaporizes and the tail grows larger. And when it starts to move out towards the outer solar system, less and less vaporizes and the tail shrinks. But notice that at every stage, the tail is always pointing away from the sun. Now, the dust tail does actually get a bit of an arc to it because sunlight doesn't push very hard, so it takes a while for the material to drift away. So it does lead to this arc in the dust tail. The plasma tail pretty much does always point directly away from the sun.